This hearing will come to order. Good morning, everyone, and welcome to today's hearing on the opportunities and challenges related to the expansion of our nuclear power industry. As usual, we have a lot going on this morning, so we'll have members coming in from their other meetings. Also, to let you know, this is being televised, so we have staff and other interested people watching, so your words will go out broadly, and we're glad you're here for this very good discussion. And I would like to welcome our expert panelists who will share with us their views about the role of the federal government to advance electricity production from the nuclear power and its ability to help address the pressing problems of climate change. There's no doubt we are witnessing a renewed interest in nuclear power production overseas and here in the U.S. Controls of greenhouse gas emissions, federal incentives authorized in the Energy Policy Act of 2005, and higher fossil fuel prices are all motivating this renewed interest. The Nuclear Regulatory Commission is anticipating over 30 U.S. applications for new reactors through 2009, and another 150 are planned or proposed globally. Existing nuclear power plants provide approximately 20% of our nation's electricity, and they do so as a carbon or low carbon emitter. Improvements in performance at our nuclear facilities over the years have made them a reliable source of baseload electricity. However, expanded use of nuclear power won't come without some major cost. Construction of new nuclear power plants is expensive. In addition, other issues that need to be considered are the risk of nuclear weapons proliferation, management of radioactive waste generated by the nuclear power, and the cost to the taxpayers of possible additional federal subsidies to the industry. The technical challenges of expanded nuclear power production should be met with an aggressive research and development program. The administration has been a strong advocate of expanded financial support for the industry. In my view, support for research and development to address the challenges associated with expanded nuclear power production is equally important. I believe that we must maintain a diverse and robust energy production portfolio in the United States. We need reliable and affordable electricity generation to maintain our quality of life and ensure we remain globally competitive. We must have a strategy that maintains our economic viability without turning a blind eye to the tremendous challenge of climate change. The details of a national climate change program are not very clear, but I believe it is critical that we have a comprehensive and meaningful technology strategy to ensure we can meet targeted reductions of greenhouse gas emissions in a rapid time frame. I look forward to a lively discussion this morning about the potential for nuclear power to provide more of our electricity in the United States than abroad. And at this time, I would like to yield to my friend, the distinguished colleague from California, and our today's ranking member for his opening statement.
Thank you, Mr. Chairman. I appreciate this hearing today, and I think that this issue is one that has been waiting for a long time to have a frank and open discussion about. Mr. Chairman, nearly 1 billion people around the world celebrated Earth Day yesterday or earlier this week, and frankly, you heard a lot of communication and talk about countless alternatives for energy. We've talked about alternative energy sources such as wind and the use of hydroelectric, and you can go down the whole thing. What's interesting is if you listen to all of the talk, there was nothing mentioned about nuclear power, as if it was a black hole that was not allowed to be discussed. And I think that when we confront the issue that over the next 25 years, we're going to be confronted with a 30% increase in electricity demand at a time that is going to potentially increase CO emissions by 16%, when we need to be reducing those numbers by a dramatic number within the next 30 years. The fact is that if we go down and talk about solar, we talk about different items on this, the politically correct concept that we are not allowed to say the N-word has to be thrown away. This is not a dogma. If we want to be truly protective of the environment and the economy, we have to approach this from a scientific base. This is not a theology. A global strategy for climate change control has been backed by numerous world leaders and scientific experts. The Executive Secretary of the United Nations Framework Convention on Climate Change noted and that he said they'd never seen a credible scenario for reducing greenhouse gas emissions that did not include nuclear power. Now, we can go back and say that the Intergovernmental Panel on Climate Change, which won the 2007 Nobel Peace Prize along with Vice President Gore, noted in their report the need for nuclear energy. In the IPCC's report on climate change, the fourth assessment report of Intergovernmental Panel on Climate Change, the panel identified nuclear energy as being a key technology in addressing global change. And in fact, the IPCC reported that the robust mix of energy sources, including nuclear, are almost certainly to be required if we're going to reach our demands. So I just think we need to start off this right out front, that let's be willing to say what needs to be said. I just had a meeting with a colleague that you may remember, Mary Nichols, who used to be with the EPA. And as a former member of the Air Resources Board, she is now the chair of the Air Resources Board for California. California is confronted with the reality that their blanket abolition against nuclear power has to be revisited, and if they truly want to address the climate issue, they've got to be brave enough to step up and address this issue up front. So I appreciate the fact that you've been able to have this hearing today. The United States has not built a new nuclear plant in 20 years, and this has really been harmful. With all of the concerns about nuclear, the alternatives are not acceptable. And so I appreciate the fact that we're able to have this discussion, and hopefully, Mr. Chairman, this will be the beginning of a bipartisan approach at saying not how do we abandon a technology that is essential for our future, but how do we work together to make it work so that we can save the climate and leave our children and grandchildren a prosperous future. And I yield back, Mr. Chairman.
Thank you, Mr. Bilbrey. I hope as this hearing goes forward, you'll let us know how you really feel about nuclear power. I ask unanimous consent that all additional opening statements submitted by committee members be included in the record. Without objection, it's now my pleasure to introduce our witnesses this morning. First, Ms. Marilyn Kray is the president of NuStart Energy and also the vice president of project development at Exelon Nuclear. Welcome. Dr. Robert Van Namen is the senior vice president of uranium enrichment at the United States Enrichment Corporation. Welcome to you. Dr. Jim Asselstine is the recently retired managing director at Lehman Brothers and a former commissioner of the Nuclear Regulatory Commission. We welcome you. And Dr. Thomas Cochran is a senior scientist in the nuclear program at the National Resources Defense Council. Welcome. And Dr. Robert Fry is a visiting scholar at the Resources for the Future and a chair of a recent study conducted by the National Academies on the Department of Energy Nuclear Research and Development Program. And finally, Dr. Admiral or Vice Admiral John Grossenbacher is the director of the Idaho National Laboratory. I think that I want to compliment our majority staff for pulling together an outstanding panel I think with diverse views that will help us start this process of better understanding the role of nuclear power as we move forward. And I will say to the witnesses, you each will have 5 minutes of your spoken testimony. We want to try to be crisp with that, but we are not going to cut you off if you have more good things to say. Your written testimony will be included in the record for the hearing, and when you are complete your testimony, we will begin the questions. Each member will have 5 minutes to question the panel. So, Ms. Kray, you may begin.
Good morning, Chairman Gordon, Congressman Bilbrey, and members of the committee. As mentioned, I am a vice president with Exelon Nuclear. Exelon is the largest operator of nuclear plants in the United States. I'm here today in my role also as president of NuStart Energy Development. The NuStart Consortium is comprised of 10 power companies and 2 reactor vendors. The consortium was formed in 2004 based on a shared vision as well as a shared sense of responsibility. The shared vision was that the nuclear industry would be called upon at some point in the future to provide additional baseload capacity, and the shared responsibility is that it was our job to take actions in order to make us ready for that. The need for new nuclear plants arises from a platform of change that is brought about by both the electricity demand as well as mentioned the environmental awareness. You may know the EIA projects electricity demand to increase by 30% by the year 2030. With respect to environmental awareness, nuclear power accounts for 73% of the carbon-free generation. To put it in perspective also, the volume of greenhouse gas avoided by the production with nuclear power is approximately equal to 96% of the passenger cars that are on the road today. Mr. Chairman, I stress that the consideration of additional nuclear is not to the exclusion of any other baseload generation, in particular renewables, but rather it is our attempt to uphold the current 20% contribution that nuclear is making, given the expected growth in demand. As the title of this hearing suggests, the opportunities for nuclear plants must be considered along with the challenges. My testimony outlines a number of challenges, but in response to your invitation letter, I would like to address a few of those, including licensing, cost, and also workforce development. Demonstrating the licensing process is one of the objectives of the NuStart Consortium. To date, there have been 9 combined construction and operating license applications submitted to the NRC. 6 of these 9 were submitted by NuStart members. NuStart members plan to submit an additional 4 applications by the end of this calendar year. My observations to date of the licensing process is that it is going well. However, I caution that we are only a few months into a multi-year review. There are 2 aspects of the process, however, that I believe have yielded the success to date, but more importantly will continue in the ongoing success of the process. They are first, the commitment to design standardization for the new fleet of plants, and also the communication between the NRC staff and the industry. You may know one of the components of an application is the final safety analysis report. For the 2 selected technologies by NuStart, those are the Westinghouse Advanced Passive 1000 reactor and the GE Hitachi Economic Simplified Boiling Water Reactor, the FSAR is approximately 75 to 80% identical for all applicants of that technology. And although the premise of plant standardization is operational, safety, and efficiency, it will greatly facilitate the NRC's design-centered review approach. And that is where the NRC needs to review an issue only one time. That yields, of course, the regulatory efficiency, and NuStart remains the optimum forum for this industry coordination. The other cornerstone of the licensing process is the communication, as I mentioned. Over a year and a half ago, the NRC began to conduct public workshops wherein they conveyed their expectations with respect to content of applications. Also during this pre-submittal phase, there were numerous public visits by the NRC staff to the various sites and also public meetings, again, wherein we could get ongoing feedback regarding the development of our application. This continued throughout the sufficiency review, and we expect that it will continue through the intense safety environmental reviews. On the next challenge of cost, I offer you my utility perspective, and that is that any investment in a new plant will only be made if it's in the best interest to both our shareholders as well as our customers. We are not predisposed to nuclear generation. Whether it is a board of directors decision or that of a state public utility commission, a nuclear investment must be proven to be superior to the other energy alternatives. We are concerned not only with the initial cost of the plant, but the long-term stability of electricity rates over the life of the plant. Contrary to what you may hear from my fellow panelists, I believe government incentives are needed to address our energy investment crisis. And these incentives must equitably treat each component of the diverse portfolio. The third area of workforce development, while it is a challenge to new nuclear plants, it is a tremendous opportunity for students, workers, and businesses. The nuclear industry needs a wealth of engineering expertise and skilled labor to design, construct, and operate the next fleet of plants. The industry is taking aggressive action to develop its future workforce. Some of these actions include outreach efforts with professional societies, developing training programs and partnerships through high schools, union and apprenticeship programs, community colleges, and universities. Success in these areas is needed to not only staff the existing fleet, but also the fleets of the future. Lastly, I want to leave you with my outlook for the expansion of nuclear power. And again, speaking from my utility perspective, I would characterize it at this point as cautiously optimistic. A few years ago, the nuclear strategy was to keep the option open. But now, based on conservative and phased decision-making, we have seen the optimism grow, as evidenced by the number of utilities that have either submitted or declared their intent to submit a license application, the placement of orders for long lead equipment, and most recently, the actual signing of an engineering procurement and construction agreement. We thank Congress for its vision through the Energy Policy Act in establishing the framework through which we accomplished many of these milestones, and I thank the committee for the interest in the expansion of nuclear power and the opportunity to appear before you today. Thank you.
Thank you. And Mr. Van Namen.
Yes, good morning. My name is Robert Van Namen, and I am the Senior Vice President, Uranium Enrichment for USEC, Inc., a leading supplier of nuclear fuel for commercial nuclear power plants. Thank you, Chairman Gordon, Congressman Bilbray, and members of the committee for inviting me to testify. Today's nuclear fuel supply is in transition. While in better shape than a decade ago, much remains to be done to support the expansion of nuclear power. Domestic companies constructing new facilities face stiff competition in a market dominated by foreign, vertically integrated firms. As we increase our capacity, U.S. companies need the assurance that their investment of resources will receive the support necessary to revive the industry to a self-sustaining position. Unless we take steps now, we will lose our ability to affect nuclear's future expansion and use. Let's start with mining and milling of natural uranium. Since 1994, domestic sources have provided about 18% of the uranium purchased by U.S. reactors. Since 2003, the price of uranium has risen from $10 a pound to more than $95 a pound for long-term contracts. At this price, domestic miners have begun to expand or restart existing mines. While it is unlikely we would ever be able to supply all of our needs with domestic production, the countries with the greatest uranium reserves are close allies. The Department of Energy also maintains a large inventory of uranium in various forms. The second step of the fuel cycle is conversion of natural uranium to uranium hexafluoride. The lone U.S. supplier of conversion, the Converdyne plant in Illinois, has recently expanded and can now meet about 80% of U.S. demand. After conversion, uranium must be enriched to raise the concentration of the fissionable isotope uranium-235. The United States has one operating uranium enrichment plant, the Paducah Gaseous Diffusion Plant in Kentucky. USEC operates under lease from DOE. Domestic supplies come from three main sources: the Paducah plant, about 12%, the Megatons to Megawatts program, where USEC supplies about 43% of the market from LEU, blended down from Russian nuclear warhead material, and European producers make up the rest of the market needs from their overseas production. The enrichment industry is transitioning to production based almost solely on gas centrifuge. One advantage of gas centrifuge is modularity. As contracts are signed, a plant can be expanded in increments. As we see new reactors constructed, we have the ability to expand in order to meet the demand. In the United States, USEC and another company are each building a gas centrifuge plant. Others are contemplating building here. If all are constructed, it could supply the U.S. needs and be expanded as needed to meet growth in market. If required, the Paducah Gaseous Diffusion Plant could also run past its planned shutdown in 2012. I would like to speak for a moment about the American centrifuge plant. The ACP is the only plant to use U.S. centrifuge technology. Owned and operated by a U.S. company, it is the only technology that can be used to meet national security needs, but at the same time does not benefit from foreign government ownership and support as does its competitors. USEC's development and manufacturing work is based in Oak Ridge, Tennessee. Manufacturing of machine components will also take place in several other states. We are at a critical juncture as we enter in the process of deploying the plant and are looking to have it at capacity by 2012 to meet market demand. The final portion of the fuel cycle, fuel fabrication, is served by several plants in the United States. Currently, the market has much more supply than demand. If new reactors are built, existing fabrication facilities should have enough capacity to meet demand. Several threats to nuclear expansion exist. One is timely and adequate financing for construction in light of current credit market conditions and uncertainty regarding the timing of any loan guarantees from the Department of Energy. The companies building here also need to be able to compete on a level playing field. The potential for Russia to dump low-enriched uranium on the U.S. market is indeed a threat. I would like to close by discussing the role that the U.S. government can play in solidifying the U.S.-based fuel supply. Despite actions by Congress to encourage the expansion of nuclear power, the implementation of legislative directives at the agency level has lagged behind market needs. Delays in implementing the loan guarantee program is one example. Domestic producers need legislative support to ensure that the U.S. government can effectively enforce the Russian suspension agreement. Additionally, support for the Paducah plant with a contract to enrich the Department of Energy's high-assay tails would help meet market needs for both uranium and enrichment. DOE needs to complete its plan for managing and selling its uranium inventory to provide market clarity on how DOE's inventories will affect supply. Our mutual goal should be the expansion of nuclear power. The domestic fuel industry is working to ensure that the fuel for nuclear reactors will be available when they come online. At USEC, we firmly believe that increasing our use of nuclear power will help our nation tackle the challenges we face, from international energy security to the adverse effects of burning fossil fuels. Thank you for your time, and I look forward to the questions.
Thank you. And Mr. Asselstine, you're recognized.
Mr. Chairman, Congressman Bilbray, members of the committee, thank you for the opportunity to appear before you today. My testimony will provide a financial community perspective on the major issues of financial institutions regarding investment in new nuclear power plants. In addition, I will discuss the role of the federal financial support in private sector decisions to invest in nuclear power. As the companies and their investors evaluate a potential new nuclear plant project, I believe that they will need to consider several factors. First, the companies and investors are mindful of the experience with construction delays, cost increases, and licensing and litigation delays for many of the existing plants that entered commercial operation in the 1980s and 1990s. They will want to be satisfied that the causes for these past problems have been addressed for any new project. Second, given the construction complexity and large capital investment for a new nuclear project, the companies and investors will want to be confident that a new project can be completed on budget and on schedule. Third, the companies and investors will want assurance that technology risk for the project is relatively low, because all of the new plant projects being contemplated use technology that is similar to the light water reactor designs of the existing plants, and because those plants have established a consistent track record of safe and reliable operation, I don't believe that technology risk is a significant factor. Fourth, the companies and their investors will want assurance that the risk of cost increases due to new regulatory requirements and licensing and litigation delays is acceptably low. The existing light water reactor technology in use today is much more mature than it was when many of the existing plants were licensed, and we now have an extensive base of successful operating experience with the existing plants. In addition, a number of issues, such as the post-3 Mile Island changes, fire protection, equipment reliability, material conditions and metallurgy, and maintenance issues have been addressed satisfactorily by the industry and the NRC. Further, over the past decade, we have had a period of regulatory stability with the NRC that has contributed to the successful operation of the existing plants. Thus, although there is the potential for additional regulatory requirements to address issues such as plant security and material condition as the existing plants grow older, the risk of costly and disruptive new regulatory requirements for new plants appears to be relatively low. Similarly, the adoption of a new licensing process by the NRC for future nuclear plants that is intended to address the causes of delays and cost increases in the past is encouraging. But until licensing decisions have been completed for a group of initial new plants, that new licensing process remains untested, and some uncertainty remains as to whether the process will function as it is intended. Fifth, The companies and investors will require assurance that the price of power to be generated by a new nuclear plant will be competitive with other alternatives, including coal and gas-fired generation and renewable energy resources. This may pose a special challenge for the initial group of new nuclear plants because it is likely that the industry will incur $300 to $500 million in first-of-a-kind engineering costs for each new nuclear plant design in order to develop the detailed engineering design information required to satisfy the NRC's design certification process. Depending upon how these costs are allocated, this could significantly increase the cost of the initial new plants. And finally, as is the case with any new proposed generating project, the companies and investors will need confidence that the power from the new plant is needed and that the company will be able to recover its capital investment in the plant and earn a fair return on that investment. Mr. Chairman, I believe that a number of these factors can be addressed by the industry through the contractual arrangements for construction and risk sharing among the parties involved in designing, building, owning, and operating a new nuclear plant. But some factors, such as the magnitude, complexity, and large initial capital investment, including the engineering design costs that I mentioned, of a new nuclear project, and residual uncertainties associated with the new but as yet untested NRC licensing process, will likely require federal financial support to allow the companies and investors to move forward with new nuclear plant commitments. Mr. Chairman, I believe the financial support provisions in the Energy Policy Act of 2005, if properly implemented, can provide a sufficient basis to support the development and financing of new nuclear plants in this country. As you mentioned in your opening statement, there is clear evidence from the level of activity within the industry since the Energy Policy Act was enacted that these provisions in the Act are having their intended effect of facilitating and encouraging new nuclear plant development. Continued successful implementation of all three of the key financial support components in the Energy Policy Act of 2005 will be essential if this industry activity is to be converted into firm orders for new plants. Final implementing regulations are now in effect by the Department of Energy for the standby delay risk insurance provision and the Federal Loan Guarantee Program. In addition, final regulations are now in effect by the Internal Revenue Service for the production tax credit provision. In general, I believe that these regulations provide a workable framework for implementing the three financial support provisions in the Energy Policy Act. In particular, though, considerable work remains to be done regarding the Federal Loan Guarantee Program. And that's the area that I believe will require some additional ongoing congressional oversight and involvement with. Mr. Chairman, again, thank you for the opportunity to testify today, and that completes my
Thank you. And Mr. Cochran, you're recognized for 5 minutes.
Chairman, thank you, and thank you for providing the Natural Resources Defense Council with the opportunity to testify today. I've provided in my testimony a summary of recommendations for the Congress. The highest priority, I believe, is to pass a climate bill that puts stringent limits on CO2 emissions and other greenhouse gas emissions. This is not only the best and most economically efficient way to mitigate climate change, but it is the single policy that would provide the greatest benefit to the domestic nuclear power industry. Secondly, the Congress should stop subsidizing the construction of new nuclear power plants and reject further subsidies for new nuclear plants in climate mitigation legislation. The economically inefficient way to mitigate climate change is to continue to subsidize new nuclear plants. This will penalize and slow investments in improved energy efficiency and energy supply technologies that can mitigate climate change in less time with less cost and risk. Third, you should terminate the Department of Energy's misguided 100-plus year effort to close the nuclear fuel cycle and introduce fast burner reactors into the United States, and terminate funding for research on advanced nuclear fuel reprocessing. You should establish an unbiased outside commission to report on ways to improve the Nuclear Regulatory Commission's safety culture. The biggest barrier to significant improvement of U.S. nuclear plant safety is the poor safety culture of the Nuclear Regulatory Commission. Finally, you should initiate a search, or have the Department of Energy initiate a search for a second geologic repository for the disposal of spent fuel. Nuclear power has both benefits and costs. On the benefit side, it's a low carbon emitter, it's a reliable generator of electricity, it provides low cost electricity from existing plants, it has a reliable and plentiful supply of fuel, and low health impacts from routine plant emissions. On the other side of the ledger, it increases the risk of nuclear weapons proliferation. You run the risk of another catastrophic nuclear accident. It has significant unresolved waste disposal problems. It has significant unresolved health and environmental problems associated with uranium mining. And new nuclear plants will not be economical in the United States until competing fossil generation is required to pay significant financial penalty for its carbon emissions. Polluter should pay, and efficient way to deal with that issue is to cap carbon. Now, I've provided an analysis of the projections of nuclear power globally based on the World Nuclear Association's database. This is a snapshot of all the reactors in operation, under construction, planned, and proposed. And if you look at those, the future of that set of reactors, this snapshot, and ask what's the climate mitigation offset, the carbon emission avoided, you see it's about over and above what it would be today if you maintain the current global level of nuclear power. The growth is about 6% of what's needed to address this climate change problem. Now, that's number is very uncertain. It could certainly be twice that, because that number does not include nuclear plants from the 2030 to 2050 period, because that's beyond the horizon for companies to propose new plants. But nuclear has made a contribution to climate mitigation. It will continue to make a contribution to climate mitigation. And the issue for the Congress and for us is not whether you are for or against nuclear power. The climate issue, in terms of domestic policy, is whether the Congress, the federal government, should continue to subsidize new nuclear plant construction. And in our view, the Congress should not. And I've stated earlier why I think that would actually slow the process down by curtailing investments in technologies that can get us there sooner and at less risk. Now, it's also, I believe, additional subsidies are not needed. Friend Marilyn Kray is president of NuStart. NuStart participants, the 10 utilities, own or operate 2/3 of the nuclear power plants in this country. They have a combined assets of, I don't know the precise figure, but I would say on the order of $400 billion. The General Electric Company, which is also a participant, the second largest corporation in the world, has assets of $400 billion alone. You do not need to subsidize these people. They can provide the risk insurance for their own investments by collaborating as they've done in NuStart.
Mr. Cochran, if you could, we're trying to be generous with the time, but if you might bring it to a close, and we can explore your suggestions in the questions.
Sure. Well, let me just say that the greatest concern I have about the global expansion of nuclear power is the proliferation risk. And the international safeguards regime, the Non-Proliferation Treaty, the IAEA safeguards and other elements, not adequate today to safeguard many of the fuel cycle facilities that are used by the nuclear power industry globally. And we see that being played out in Iran and North Korea. And it's unfortunate, but all of the big problems with nuclear have been fostered over onto the federal government for various reasons. Proliferation, that's a government problem. Safety of catastrophic accidents, the government assumes the risk of catastrophic accidents. Waste is so toxic and it contains plutonium, it can be used for weapons. That's a government problem. The government is not solving these problems. These problems are endemic and they remain. And you've got to address these fundamental problems before we expand nuclear power significantly on a global basis.
Thank you, Mr. Cochran. And Mr. Fry, you're recognized.
Thank you, Mr. Chairman, and Mr. Bilbray, and members of the committee. I'm here today representing the National Research Council, where I served as chair of a committee to review DOE's nuclear energy R&D budget. We submitted our report last October, and I'd like to just touch on some of the highlights from it. We examined 4 major R&D programs, the funding for which is on the order of $300 to $400 million a year, that are managed by the Office of Nuclear Energy and the Department of Energy. They were what's called Nuclear Power NP 2010, which is a program cost shared with industry to assist in the licensing of the first nuclear plants in the U.S. in over 30 years. And 3 real research programs, one, the Generation 4 class of nuclear reactors, secondly, the Nuclear Hydrogen Initiative, and finally, the Advanced Fuel Cycle Initiative, which is a program aimed to develop technologies to close the back end of the nuclear fuel cycle. The committee recommended that the department give the highest priority to NP 2010. If nuclear power is to play a major role in the nation's energy picture, it's simply essential to license, build, and operate the first of the next generation of reactors. And given the long lead times and construction periods involved, it's important to do it now. The committee also noted that the human and intellectual infrastructure needed to support this effort has been aging, and therefore we specifically recommended, first, continued support of university programs in nuclear science and engineering, and secondly, consideration of the appropriate research support for the nuclear industry, for example, through the provision of national user facilities such as the Advanced Test Reactor at the Idaho National Laboratory. Now, the same sense of urgency, however, did not attend the other programs we examined. There are acceptable methods of storing spent nuclear fuel safely for decades without reprocessing and fuel recycling. Doesn't seem to be a serious shortage of uranium for reactor fuel. It's certainly not one that's going to emerge for many years. And moreover, we concluded that it will take considerable time for the information to be developed to change these judgments. Now, this is not to say that research in new reactor design or hydrogen production or closing the fuel cycle should not go on. Indeed, our committee recommended that it should. However, the research program should be designed to lay the basis for deployment of these technologies sometime in the future when circumstances warrant. And to this end, funding at a sustainable level over time is more important, it seems to us, than speed. And we strongly urge the development of an independent oversight function that would help ensure that the advanced research programs stay on track over an extended period of time, continue to be responsive to the changing external environment. We also concluded that the development of large-scale facilities for closing the nuclear fuel cycle would be inconsistent with our assessment of priorities. For this reason, and because of the very large technical risk involved in an overly aggressive construction program, we recommended against the funding of such facilities in the near term. Thank you, Mr. Chairman, and I look forward to your questions. No, I was actually at an end.
Oh, it was good timing then. Very good timing. Okay. Dr. Admiral Grossenbacher.
Mr. Chairman, Congressman Bilbray, members of the committee, good morning, and thank you for providing me the opportunity to speak with you on a subject of great importance to our country, nuclear power and the opportunities and challenges associated with it. It's a privilege for me to represent the 3,800 scientists, engineers, skilled technicians, and support staff of the Idaho National Laboratory. At the dawn of the nuclear age, the Idaho National Laboratory was our nation's reactor laboratory, developing and demonstrating a range of technologies from boiling water reactors to breeder reactors, gas-cooled, reactors cooled by organic coolants, over 52 different reactors. As we consider the role of nuclear energy in our nation's and the world's energy portfolio, the people of the Idaho National Laboratory are eager to collaborate with university colleagues, nationally and internationally experienced industry technical leaders, and the system of laboratories and their unique capabilities within the Department of Energy. We are eager to collaborate to answer the difficult questions that should guide our nation's and the world's choice of our future energy portfolio. Technology provides the means to an end. We humans have chosen an energy-dense existence as an end, with attendant benefits, enormous benefits, costs, and risks associated with the means. Our choices as we modify that end and adjust those means should be informed by disciplined, technically sound research, development, and demonstration that illuminates our choices. DOE's nuclear energy program attempts to do just that. Nuclear Power 2010 Light Water Reactor R&D, the Advanced Fuel Cycle Initiative, Generation 4 Nuclear Energy Systems Development, and investments in our human capital, very importantly at our universities, are the elements of the DOE nuclear energy program. As has been mentioned, Nuclear Power 2010 is a public-private initiative that reduces technical, institutional, and regulatory barriers to new plant development. Light Water Reactor RD&D intends to bring the enormous technical capabilities of the Department of Energy's laboratories to bear on current and future light water reactor performance issues in partnership with industry and engaging the creativity of our universities. The Advanced Fuel Cycle Initiative is the domestic technology development and deployment component of GNEP, the Global Nuclear Energy Partnership, a significant policy initiative intended to develop and demonstrate advanced fuel cycle technologies that will increase the efficiency with which we use nuclear fuel and decrease the waste burden of the nuclear fuel cycle. GNEP is intended to also provide a nuclear materials management system that addresses proliferation risks, and all in an environment that is relevant in a world where the use of nuclear energy is expanding and expanding rapidly. Generation 4 nuclear energy systems development is intended to enhance the economic, safety, physical protection, improve waste management, and reduce proliferation risk of reactors and fuel cycles beyond the light water reactor technologies we use today. The NGNP, the Next Generation Nuclear Plant, is a significant element of this program intended to develop and demonstrate a reactor after next technology that can expand the use of nuclear energy beyond electricity generation to the provision of industrial process heat. DOE's nuclear energy program engages the next generation of nuclear scientists, engineers, and technicians through its university and intern programs. It is also looking to the future and addressing how we sustain our nuclear science and technology infrastructures both inside and outside the Department of Energy. In conclusion, Mr. Chairman, the Department of Energy's nuclear energy program is intended to provide us with informed choice and opportunities for the use of nuclear energy in our current and future energy portfolio. We at the Idaho National Laboratory are proud, as the nation's nuclear energy laboratory, to have a leadership role in this very important work. Thank you very much.
At this point, we will open our first round of questions, and the chair recognizes himself for 5 minutes. I've heard a variety of concerns about the implementation of the GNAP program, so I want to better understand that, and I would like for, I have some questions for Admiral Grossenbacher and Mr. Fry. First, can either of you provide me with a cost estimate? Are we talking hundreds of millions, billions, or tens of millions of dollars?
The report uses tens of billions, although at the time we did the report, we didn't have a really definitive cost estimate.
I agree with that. For the long-term implementation of the technology, it's a significant investment over a long period of time.
Okay. Well, that is a very huge investment of taxpayer dollars, and with that understanding, I would like to clarify that the department aims to deploy commercial-scale facilities at some point to accomplish two main goals: waste reduction and non-proliferation of weapons-grade materials. Has a process for recycling spent fuel that meets that goals, or the goals I stated, been identified, and if so, is it ready for commercial deployment?
I think in the committee's view, the short answer to that is certainly not ready for commercial deployment. There are several processes that could be examined, and what we recommended was that this department systematically sort through those to determine the one that looks the most promising in light of what else is going on in the world, and ultimately that to commercial scale.
You concur with that, Admiral?
Mr. Chairman, the only thing I want to add is that you said waste reduction. That's true. The other intention is resource utilization, remembering that the current once-through fuel cycle only uses a very small percentage of the uranium, the potential,
But in terms of the recycling, the fuel, that process is not ready for commercialization. Is that correct? Would you concur with Mr. Fries?
Not as envisioned in GNAP. Certainly there are recycling technologies that are industrialized today, but not.
Well, that's
not
what I
as
was trying to get
envisioned
to the
in
GNAP program.
Yeah.
Okay, Admiral, so spending billions of taxpayer dollars on commercial scale facilities before the necessary research and development has been conducted, it's a little hard for me to understand. It has been reported that the department is moving away from that strategy. Can you confirm that for me?
The short answer is no. I can't. I don't know the precise details of the current discussion about GNAP. I feel it's important to remind you that this is meant to be a development and demonstration program that is evolutionary, and that you have to start somewhere.
So don't you start with research rather than with
sure you do.
forward
Yes, sir,
a
Mr.
full-scale tens of billions of dollar commercialization? And with all the needs here, I mean, is this, I guess what I'm trying to, with limited dollars,
right,
is this the best way to spend those dollars? And is this a focused way? And, quite frankly, there's been concern in many areas that there wasn't a lot of collaboration, that this doesn't really, it was a sort of everything for everybody. And I'm concerned, again, if we're going to make this investment, I want to make it in the best possible way.
Yes, sir. I think that's a valid point. The only thing I want to point out is if you look at the goals of GNAP, which, from a technology point of view, which are ambitious, the key question is what's the time frame, and when do you go to a full-scale industrial demonstration of that technology, and what technology do you choose? And that has to be informed by both an R&D process and the involvement of the industry. The laboratories, the scientists and engineers don't build and operate these large-scale industrial facilities. So I think it's all in, the issue is what's the time frame that you're
part of that,
about.
the issue also is having a broad enough buy-in that you can keep a flow of taxpayer dollars going to feel comfortable and complete this. So just real quickly, Dr. Cochran or Mr. Fry, would you want to comment on this issue?
Only to say that our report, we've said, while we don't see the virtue in spending a lot of money right now for big commercial facilities, it's a long-term program. Kind of the quid pro quo is it is a long-term program, and therefore sustained commitment and sustained funding is really important to the success of that program. And that kind of stability is not something that the nuclear R&D budget has experienced over the last several years. And it's something that I hope that the Congress will be able to sustain at a reasonable level over a long enough period of time with the appropriate outside advice so that they can get the job done.
Quickly, what is the appropriate outside advice? And who would that be? Or not what is it, but who's the vehicle for that?
We recommended that the department set up an outside advisory committee that's independent, objective, and has a strategic focus. What we have in mind, to put it an analogy that may be familiar to you, or something like the science advisory committees at the Department of Energy, which is composed of people of the community, but as you know, they're perfectly willing to tell the department when they're wrong.
Yeah.
And that's what is needed.
I think that's
in the
important. I don't want to abuse my time, and I know Mr. Cochran's probably squirming in his seat, so why don't you have a closing statement on this topic?
Mr. Chairman, the GNAP program is doomed to failure. The vision requires that roughly for every 100 gigawatts of thermal reactor capacity, the type of reactors we have today, you would need roughly 40 to 75 gigawatts of fast reactor capacity. And fast reactors have been under development in this country and around the world since 1946. The programs to develop fast breeder reactors were failures in the United States, in France, in the United Kingdom, in Germany, in Italy, in Japan, and I would also argue in Russia. The flagships of these programs were all failures. Monju had an accident, was shut down in '95 and hadn't restarted. Super Phoenix in France had a lifetime capacity factor of between 6 and 7%. The Clinch River reactor was canceled. We've left the FFTF sitting around in the state of Washington and folded that program back into the very small EBR-1 reactor, EBR-2 reactor at Idaho. The German reactor was canceled before it was fueled, and it's been turned into a hotel and amusement park, and is probably the only fast reactor that has ever made money. The British fast reactor program was canceled. The Italian ones never got off the ground. The Russians never put plutonium in their fast reactor.
Well, Mr. Cochran, I don't want to abuse my time. I think the short answer there is that clearly this needs to be rethought to make sure that we are, with this past history, that we are spending those limited dollars.
One more point.
Okay.
Because this program is doomed to failure, because these programs are unreliable, I didn't mention, by the way, it was a failure in two navies. The United States Navy, Admiral Rickover jerked it out of the Seawolf, and in the Soviet Navy. But what is going to happen is the R&D is going to go forward, and the Department of Energy is promoting this R&D not only in weapon states but in non-weapon states. And what we are doing is training people in actinide chemistry and plutonium metallurgy, and the proliferation risks are going to increase from the R&D programs, and they will never decrease from the deployment of the program.
Thank you. And Mr. Bilbrey is recognized for 5 minutes.
Thank you very much, Mr. Chairman. Mr. Cochran, I'm looking at the concerns about the environmental challenges of nuclear. The Natural Resource Defense Council basically, does it support more emphasis on hydroelectric, wind, geothermal and solar?
Our highest priority is to mitigate the climate effects of global warming. And that means that our highest priority is to get a climate bill through the Congress. And that means, since it is the single policy that will do the nuclear industry the most good, we are in a situation where the Natural Resources Defense Council is an advocate for the single policy that would do the U.S. nuclear industry the most good.
Well, that's a great attitude to have. I appreciate that. I think we've talked about hydroelectric, and we realize the environmental problems of dam and the construction and whatever. And I want to make sure that, you know, your group identifies the environmental challenges to all the options.
We do, and we have programs across the board to internalize the externalities associated with all of these energy technologies.
When you do
nuclear,
wind, solar, and geothermal seem to appear to be a very small environmental footprint. Wouldn't you agree? In at least first appearances.
yes.
Can you articulate at all the unseen environmental impacts of those three choices?
Well, the primary problems associated with wind today are not environmental problems there. I mean, other than aesthetics, some people think it looks good, some people think it's an eyesore. But the primary problems with wind relate to its cost and the fact that the wind doesn't blow 100% of the time, so the average capacity factor of a wind farm would be more like 25 to 30% rather than the 90% of a capacity factor of U.S. nuclear plants in today. Solar, I think solar can, the main problems have to do with cost, but the environmental problems are quite small. They're not zero. I think we need to internalize the environmental costs of all of the technologies.
Doctor, I have to apologize to you because I've sort of got an inside track here. But as you know, California has tried to lead on a lot of this. And one of the things that's hit my district with these supposedly very environmentally friendly technologies is the horrendous impact that is unseen by the fact that most of what is perceived as being non-polluting, environmentally friendly technology is sited a long distance from the source of the power to the receiver, which means massive amounts of transmission capability, which has horrendous environmental impact. The greatest, probably the biggest environmental uproar right now in my county is the fact of bringing in geothermal and solar through a state park, through habitat areas and everything else. And I only want to raise that because when we talk about one technology, we sort of overlook the other technology's major environmental footprint. And so it is one of those things that I'm looking at, that what would be the environmental impact of expanding facilities that already are in San Diego County, as opposed to so-called the most environmentally friendly technologies that have to be trucked in. In fact, I think you're looking at wind generation in the whole center of the nation being proposed, but the transmission lines are not being considered in the environmental footprint. And you agree that is something that we haven't addressed enough at this state.
You know, you mentioned, for example, transmission lines. That's also a problem for nuclear plants. It's a problem for importing electricity from the Palo Verde's.
But you do agree that nuclear has the capability of being sited where plants are already sited and using existing facilities, as opposed to wind, solar, and geothermal are really site-specific, limited to certain locations that have to be sited at those places, and thus the transmission lines tend to be new and easements being increased.
I'd more or less agree with you. Certainly the reason new nuclear plants are going to be sited at existing sites is because it's cheaper to do it that way.
Well, and it's environmentally, usually it reduces the environmental footprint.
Sure.
Admiral, 1978, I was a 27-year-old mayor down along the border, and the whole issue of the U.S. nuclear industry shifted right out from under our feet. Could you explain what has happened with that industry in the last 30 years, and is it currently in a good shape?
Well, there are certainly people at the table that can address this more directly than I can, but I'll tell you what I see from my vantage point, and I see a much more mature industry that has learned how to deal with the complexities and challenges associated with its technology, a regulatory regime that has developed and matured, and so it operates, very, very well. I think last year, and Marilyn can correct me, but I think the capacity factor of the nuclear plants in the U.S. was 91.7%. From the point of view of safety and the safety of the workers, any industrial technology has hazards and risks associated with them. But tragically, we killed more people this year in refining sugar in this country than we did in operating nuclear power plants for 40 years. So all risks have to be discussed, I think, in context and relative. But my perspective on it is that it's a mature industry that operates very well. It needs to be a mature industry. It needs to be extremely diligent given the nature of the technologies. And the only other point I'll add, if I may, is in just the previous discussion, the other thing to remember about comparisons of energy sources is the density. Nuclear energy provides base load power, so it's a large concentrated energy source with hazards and risks associated with it. Distributed energy sources have other issues, including the complexity, including the scalability, and there's no free lunch. If we want large amounts of energy, then there are going to be costs, risks, benefits associated with them, and we have to look at all of them and do that type of comparison, I think, to make the best choices.
Thank you, Mr. Chairman.
Mr. Bilbray. Chair, I now recognize Representative McNerney.
Thank you, Mr. Chairman. One of my big concerns about nuclear power is the economics of the game. Now, it's very hard to get your hands around a good economic estimate for nuclear power for a lot of reasons. One of the reasons I understand is that it's easy to build a cheap nuclear power plant that has low safety considerations, and then the more safety you add on, the more expensive it gets, and so on. But I still don't understand why it's so difficult. I mean, there's going to be an initial capital cost, there's going to be fuel costs, there's going to be maintenance costs, and there's going to be disposal costs. Mr. Asselstine, perhaps you could address that, what the difficulty is and where I could find good information on that that's easy to understand.
Sure, Congressman. Let me start with existing plants first and operating costs. I think there we've got a very good handle on that, as one of the previous speakers just pointed out. If you look at the existing fleet of 104 operating plants today in the United States, those plants are operating highly reliably with capacity factors in excess of 90%. And if you think about the need for refueling outages, that means those plants are operating just about as efficiently as they possibly can. We also know that fuel, operating and maintenance costs, waste disposal fees, taxes add up to about, say, 2.5 cents per kilowatt hour in that range, which again is very comparable to what we see for large, efficient coal-fired power plants.
So that's your
today.
Operating costs, about
Those are
2.5
operating
cents.
costs. That's
right.
Exactly right. So then the real question becomes, as you look at new nuclear plants, what is the capital cost of the plant going to be?
Right.
How confident are we that the plant will actually be built for that cost and will enter commercial operation when it is expected to? And the variables there are, first, commodity prices. We're seeing significant increases in prices for things like steel. There are, in some instances, very limited international suppliers for some of the components that are necessary for nuclear power plants. A good example is very heavy steel forgings, which are necessary for the reactor pressure vessels, steam generators. There's only one supplier in the world for those components today, and they control the market, and prices have been moving up as well. Second, it's been 20 years since we've built a nuclear power plant in this country. Many of the suppliers that supplied the existing plants are no longer available. If you went to most of the existing nuclear plants in this country, when those plants were built, virtually all of the equipment and components in those plants came from the United States. For the new nuclear plants that will be built around the world, including in the United States, if if plants go forward, most of the components and equipment and supplies will come from international sources.
So what I'm basically hearing you saying is that the capital costs are going to be a determining factor, and it's going to be possibly high, and there's a lot of risk associated with this. So
exactly,
the lenders are going to want to take their part out of that risk.
And the same thing is true, quite frankly, for large new coal plants, especially using clean coal technology. You have the same risks and uncertainties. Marilyn can probably talk about how the industry and the companies are trying to get their arms around what those costs will be. When we get to the point where companies are signing firm orders to purchase a new nuclear power plant, which will be, in most instances, probably a few years from now, we'll have a better fix on exactly what those capital costs will be. The financing costs also then need to be determined, and for the purpose of investors will look at that investment and they'll say, how safe or how risky is this investment compared to building another type of generating plant within this industry, and what's the risk premium that needs to be built in for the capital costs. I believe that all of those costs can be dealt with, and you can end up with costs that are pretty comparable to what you would see for coal-fired generation, taking into account the financial support that the Congress provided in the Energy Policy Act, but we'll know with greater definition exactly what those costs are probably in a couple of years.
I wanted to talk a little bit about disposal too. I worked on disposal calculations as a graduate student at the New Mexico Waste Isolation Pilot Project. Any idea where we are with regard to credibility of geologic disposal, Mr. Fry?
The credibility, technical credibility, is, I think, pretty high. I mean, the National Academy of Sciences has said that that's ultimately to dispose of nuclear waste fuel. The actual mechanism by which that's going to happen and the costs and incident thereto are still pretty much up in the air. Yucca Mountain is not yet a project, and a number of alternatives to storing the spent fuel, perhaps on site. And I don't think good studies have been done of all of the array of options that are possible or their costs.
All right, thank you, Mr. Fry.
Thank you, Dr. McNerney. Next, Dr. Ehlers, recognized for 5 minutes.
Thank you, Mr. Chairman, and thank you for holding the hearing on a very important topic. Something that most people don't realize the crisis we're facing. Everyone's complaining about the increase in gasoline prices, but that's going to have a direct impact on electricity consumption and production, because more and more people will do as I've done, buy a hybrid, and very shortly we will have plug-in hybrids. There'll be all the rage because it takes less gasoline, but they do take electricity. That's just one example that we're going to face increased demand for electricity. Back when all the fuss started about whether nuclear reactors were safe or not, I did my own study on the issue, comparing coal to nuclear, and frankly, and as you know, I'm an environmentalist, I decided they were equally bad for the environment. But nuclear had a distinct advantage. The two biggest environmental problems, I felt, were the greenhouse gas production from the fossil fuel-fired plants, whether coal, oil, natural gas, and the biggest problem with the nuclear was the nuclear waste. To me, it was an easy decision as to which was best, because when you're discharging gases in the atmosphere, it's awfully hard to get them back and collect them and deal with the problem. Whereas with the nuclear waste, it's relatively small, solid, liquid,
and theoretically should be easier to deal with if you can get rid of the paranoia in society about nuclear waste. And I think there are ways of doing that. I've also, incidentally, I never talk about disposal of nuclear waste. We're kidding ourselves as we use that word. I served on a county commission, and we had, it was the Kent County Disposal System, which was a landfill. And I proposed officially that we should change it to the Kent County Waste Storage Facility, because all we're doing is storing it underground. And that's what we're talking about doing at Yucca Mountain too. But if the Congress had written the bill that this is going to be retrievable, monitored storage, I think we would have had far less difficulty selling it. People would still object, but it wouldn't be as bad as it is now. But putting the requirements on that say we have to make it safe for 10,000 years is just totally unrealistic. We could scientifically prove that. So thank you for letting me vent just a little bit. But it seems to me we have a huge amount of work ahead of us. You've just heard that from the testimony, what we have to do to get construction going again, obtaining parts, etc. But there's another important aspect, and I fought during my first years here to prevent the killing of the program that funded training for nuclear engineers. I lost the battle. The funding was killed. Universities dropped the programs. And that whole system has to be started up again. We have to develop a whole new fleet of nuclear engineers. And I think it's very, very important that we have properly trained personnel. I've always said that the problem with 3 Mile Island is that at that time there was a surplus of physicists in the country. But I said the problem was 3 Mile Island was being run by taxicab drivers, and taxicabs were being driven by physicists, which is kind of a backward way to solve a problem. So I think we have to set up good training programs, make sure we have an ample supply of nuclear engineers who can design, build, and operate nuclear reactors safely. The safety record, I think, is phenomenal for all but the Soviet Union, and reasons why that happened there, governmental as well as training. Mr. Chairman, all I'm saying here is we have to get going. We can't just depend on the industry to get started itself. The investments required are phenomenal. The security that will be provided if we don't step in and provide the assurance that things will work, there's not going to be enough security there for the industry and for the financiers to put the money in to get it going. So I think we ought to face up to our responsibility here, as well as making sure that industry assumes their fair share of the responsibility. And that's the only way it's going to happen. But it has to happen. We are literally running out of fossil fuels in the petroleum and natural gas area. We've got plenty of coal, but frankly, as I said earlier, I'd much rather nuclear power than coal-fired plants in terms of the environment, not just the greenhouse gases, but the mercury, all the other factors.
And the nuclear.
Pardon?
And the nucleates.
And the nucleates, right. So at any rate, that's the end of my sermon, and I hope we can unite on some positive action here. Thank you.
Thank you, Dr. Ehlers. We always are very much enlightened by your sermons here. So if we just all followed, then we'd have solve a lot of problems. But we'll now Chair will now recognize Mr. Chandler. 5 minutes.
Thank you, Mr. Chairman. It seems to me, in listening to all of this and following what I've been following over the years in regard to this issue, that we have, as much as anything, a public confidence problem, a significant public confidence problem, which, of course, impacts the willingness of investors to be involved significantly. Do you all have any ideas about how the industry can assist in building public confidence? The storage issue, of course, or disposal issue is I'm sure one that has to be addressed in particular in that regard. But could you give me some ideas about what could be done to to bring the public into a position where they feel more confident about moving forward with nuclear energy?
Mr. Vice Chairman, I'll voluntarily respond to that. The industry admits that we do not do a good job and we are not boastful. And that comes to our detriment when you look at public confidence. I think in the investor community, and Mr. Asselstine, correct me if I'm wrong, those who explore it, I think, come with yield a more positive view. Through the Nuclear Energy Institute, we do conduct surveys, and for those surveyed around the plants themselves, we have a very high support rate for nuclear power. What we do see, however, when we survey the more broader population is that there is a misunderstanding, in particular in the environmental area. And most people do not equate nuclear power with being carbon-free with respect to greenhouse gas and emissions. So we have taken that on as one of the issues that we do need to do. Also, there are a number of other organizations. One of our more successful one is the Young Generation Nuclear Group, which is some of the new students coming out of the universities working into the industry to help communicate that. I'd also say that in addition to the industry, the NRC has integrated public interaction very much into the licensing process. And even before any of the applications were submitted, the NRC by process would conduct a number of town meetings so as to educate people about that. So that's an opportunity at that point also for the industry to share the safety record, to share the process going forward. But so I do acknowledge that the advertising, the self-promotion is probably something that as an industry we have not made a priority, but need to going forward.
Maybe Mr. Asselstine and possibly Dr. Cochran too on this, if you don't mind, if you have any ideas.
Yeah. First, I would say from the perspective of somebody in the financial community, I think the industry has actually done a fairly effective job over the past couple of years in beginning to lay the groundwork to build support for new plant commitments. And obviously this process is going to be ongoing over the next several years. I mean, I start with the performance of the existing plants. That has been consistently strong over the past decade, and that was a very important foundation because without that, then the prospect of new commitments just wouldn't happen. So continued strong performance of the existing plants from a safety standpoint, from a regulatory standpoint, and economically is a critical initial ingredient. But what the industry has done fairly effectively, I think, over the past couple of years is begin to talk about the potential cost of a new nuclear plant, the approach that they will use in making a decision of whether to go forward or not in order to really educate the financial community and investors about how that process will unfold well in advance of when they come to investors and say, now we want to borrow several billions of dollars to build this. I think they need to continue to follow that approach going forward.
Well, in my view, the best way to get public support is to be truthful and transparent about all the risks and benefits of the technology. In looking at the industry's potential public relations problems going forward, a concern I would have is that if you look at the safety of plants, nuclear plants in the United States are safer today than they were 2 decades ago. But if you are going forward, most of the plants, new plants that are going to be introduced in the world are going into countries that do not have good safety cultures. And when one of these plants runs into a problem, as it has in the past, the good plants will suffer along with the bad ones. And so I think some attention needs to be given by the United States government to the development of an improved safety culture in the other countries that are getting into this business. The It's the safety culture at the plant that is the most significant, most important factor that affects the overall safety. It's the culture at the plant. And we've improved the culture at U.S. plants, but we have not addressed that problem on a global basis going forward.
But Mr. Five, you have something quickly to add.
One thing that might be worth looking into is the legislative and regulatory structure we have for spent fuel. Mr. Ellers is exactly right, it seems to me, in saying the structure we have requires you to prove that this stuff's going to be safe for 1,000,000 years. I chaired the committee for the National Academies that came up with that brilliant suggestion. And it's really hard to do. And it's very hard to convince the public that you can do it. And so it might not be a bad idea to take another look at that structure and
Thank you, Mr. Chandler. Chair will now recognize for 5 minutes Ms. Biggert.
Thank you, Mr. Chairman. I have to say that maybe I'm going to start venting too. I hope not. But when I came to Congress almost 10 years ago, the first thing that happened, and Argonne National Laboratory is in my district, was that the president cut the EMT, the electrometallurgical program, by $20 million. And I was hysterical that I thought this was in the first month that I was here, and I needed to get that funding back, because I really do believe and have long been an advocate in the recycling, reprocessing of spent nuclear fuel. Well, I did get the money back, and the program continued to conclusion, and I know that there are different processes, the Purex, the Urex Plus, some have mixed actinides, and so the cut down on the proliferation. But I think the three issues, or the two really, the pure plutonium and what to do with the waste are key issues. But to me, I think we should be moving much quicker than we are. And when I was the chairman of the Energy Subcommittee in the 108th and 109th Congress, we really worked on GNEP and trying to develop that. There was one sticking point, and that was that we asked the Department of Energy to do a comprehensive systems analysis rather than move right to what we thought was commercialization. And there was a disconnect there, and I think that really, it slowed down the process, but I think we would be a lot further along right now if we really had turned to the systems analysis rather than trying to the construction of a commercial scale facility. And the problem was then that the funding was cut until that systems analysis, or trying to get that, of which I was not a appropriator, so I was not involved in that, but the Appropriation Committee felt the same way. So I would like to know from Admiral Grossman, where are we now as far as moving ahead? Congress, the GAO, and the National Academies, I think, would be more accepting of what you're trying to do to close the fuel cycle. And I think this is the most important issue that we're facing is, finding alternative energies. And it has to be nuclear. I guess I come from a state that 50% of our electricity is nuclear, so we're used to it and really want to see what goes on. But I just think that we're spinning our wheels again. We're just sitting around waiting and to say we'll do it in the future. The costs only go up. The lack of nuclear energy is only going to hurt our country. We see all over the world all these building of nuclear plants, and we're sitting and reprocessing plants. We have one in Illinois that was built and then shut down by Jimmy Carter. There's at least 5 others that were built at that time.
Well, Congresswoman, I take your points, and I think they're very good ones. The reasons to reprocess are, in my opinion, are twofold. One is to get additional energy out of the uranium that you dug out of the ground. I mean, uranium and the other fissionable natural material, thorium, are limited resources. So if we look ahead, if we say nuclear energy is going to be an important element of our energy portfolio for the next 100, 200 years, then I think if you put it in that context, then resource utilization, not just the current market price of uranium, is an important consideration. In addition to that, the technologies involved in reprocessing at an industrial scale are difficult. You take highly radioactive material, and the first thing you do is dissolve it in hot nitric acid. That being said, resource utilization, the other is with increased resource utilization comes a waste disposal problem at the end of the cycle that is easier to manage. The waste is less toxic, less radioactive for a long period of time. So those are really the goals of reprocessing and then recycling. And GNEP, of course, has proposed a separation of used fuel into its components and burning the particularly difficult ones, the long-lasting, highly radioactive ones, in a fast reactor kind of technology. The systems analysis that you talk about to support that is ongoing. I think, frankly, it's limited by the number of uncertainties in what's it look like at a commercial scale. What are the economics going to be? So to move forward, what we have to do is we have to both do the research and development and involve the industry along the way.
If I might, though, if we're going to have to deal with the waste, if we put what the waste that we have now that's already accumulated, we would actually fill Yucca Mountain. If we were to be able to do the reprocessing, and if we would be able to burn and reburn that waste, that we could have a facility that would last for over a century. And I think we just have to make up, we can go ahead and build these plants and have more waste, but at some point we're going to have to decide when we can use Yucca Mountain.
Yes, ma'am. Those are the gains, that we can reduce the need for a geological repository, reduce the waste burden, the costs of the development of the industrial scale reprocessing technology, the resolution of the uncertainties. The principal uncertainty is, we know at a laboratory scale we can do the kinds of separations we want. We can parse the fuel. Can you do that at an industrial scale? Because it really does change. And then the other is, can you make the fuel that you want to burn, the particularly what I'll call the bad actors, can you make that, and can you recycle it effectively? And there's just a lot of technology unknowns in that, but the only way to resolve them is to do the research and development, involve the industrial components at the right pace, at the right level, because this is not just the business of laboratory scientists, it's the business of industrial operators, and then we'll know. Then we'll know whether or not we want to do it.
Thank you, Admiral, and thank you, Ms. Biggert. I'm having to deal with an issue collateral to this. I'm sorry to be coming and going. Mr. Baird is recognized both to question and to chair.
Thank the chairman. I think I was up to ask questions anyway, so I'll assume the chair and ask a couple of questions. I appreciate the testimony of the witnesses, and am very much in line with some of the points made by Mr. Ehlers. However, I should also say that I come from the state of Washington. I am downriver from the Hanford Nuclear Reservation, which is not cleaned by a darn sight. Obviously, it was not a nuclear power issue initially, but nevertheless is a substantial nuclear waste issue today. And we're also from the state that had the Washington Public Power Supply System debacle, the largest bond default, I think, in the history of the country up to that point. And it's not just, seems to me, I have sort of two questions. One, if somebody could give us a handle of the total net federal subsidies thus far that have gone into nuclear energy. And that would include development, design, indemnification, et cetera, et cetera. And then the second question is, what can we do if we spend it on not coal, not nuclear, but something else? And take, for example, more fuel-efficient heat sources, et cetera, et cetera. What are the returns on investment and the relative risks and costs of those? more efficient heat pumps, in-ground heat pumps, in line with Mr. Bilbray's question, don't require any new generation or any new generation or transmission capacity. So 2 questions. What about subsidies, and what about alternatives? And the final one would be if any of you want to volunteer whether or not you've asked the administration to increase funding to clean up Hanford. We would certainly welcome that. If you're asking for new money for new power plants, to clean up your mess beforehand would be great. So anybody want to take any 3 of those? Dr. Cochran?
I think it's difficult getting a handle on the total federal subsidies to nuclear power in the United States. I've seen numbers on the order of $150 billion, probably includes direct and indirect subsidies.
Total over the lifespan of the enterprise?
Yes. I mean, the industry was built on the back of the submarine program, propulsion program. It had enormous subsidies in its early career. We spent tens of billions on the fast breeder reactor and some other technologies that didn't come to fruition. It's a mature industry now. It's a 50-year-old industry in the United States, and the subsidies that are being provided today are not going to change the underlying economics between fossil fuels and nuclear, the base load energy generation.
And yet
they're basically subsidies to build a few new nuclear plants. And the only way you can change the really underlying economic differential is to internalize the true cost to society of emitting carbon. And I would use the federal subsidies. I would look to where the Wall Street money is going in terms of these energy technologies. Where's the high-risk money going out in the Palo Alto area? And it's going towards new solar technologies and a number of other areas.
Mr. Asselstine?
I would agree with Tom. I think it's very difficult to quantify the past support.
It's sunk costs anyway, but so
that's right. It's much easier to look at the financial support that's now being provided for the next generation of plants. And if you look at the Energy Policy Act, you can work through the numbers fairly easily. There's a production tax credit of 1.8 cents per kilowatt hour for up to 6,000 megawatts of new generation, very similar to the production tax credit that is provided for renewable energy resources as well. So if you took that 6,000 megawatts over 8 years with the cap of 125 million per 1,000 megawatts per year for nuclear, that's $6 billion over the 8-year time period.
But is that not somewhat specious because there's not waste disposal problems of the same magnitude? I mean, so you've got a production tax credit, which is a direct subsidy, but what about waste disposal issues, transportation, etc.?
Waste disposal, the Nuclear Waste Policy Act did impose a mandatory charge for utilities for nuclear generation that's been in effect since the mid-1980s, where the utilities have paid 1 mil per kilowatt hour for every kilowatt hour of electricity generated by nuclear power plants in the country. That money has gone to the Treasury to fund the waste disposal program. And if anything, what we've seen over that time period is the federal government failed to meet its obligation to take the waste. And if anything, courts have now been returning some of that money or compensating utilities for their ongoing storage costs. So I would argue on the waste side, the utilities were pay-as-you-go from the mid-1980s and continue that way today. And the assumption is if you have new nuclear power plants going forward, those plants will also be assessed for the waste disposal costs down the road. You can also look at the standby risk insurance, which provides protection against licensing and litigation delays for 6 units. If that risk insurance is actually needed and used, that would be about $2 billion. And the Congress has appropriated about $18.5 billion in funding for loan guarantees for the nuclear plants. Add all of those up, it's about $26 billion. If the chairman pointed out in his opening comments, we now have applications or statements from the utilities that they intend to apply for licenses for 25 to 30 new units. So the trade-off would be about $26 billion in federal support to help ensure that we might get 25 to 30 new nuclear power plants over, say, the next 20 years or so. Those 25 to 30 new plants would mean that nuclear, taking into account the Energy Information Agency's projection about growth in electricity demand, would keep nuclear at about 20% of our generating mix going forward. My own personal view is that's the Congress made a reasonable decision to provide that support to get about 25 to 30 new plants to keep nuclear at 20% of our generating mix. And why is that beneficial? It makes the challenges of dealing with carbon, with the coal-fired generation easier to deal with. It makes dealing with price volatility for natural gas somewhat easier to deal with, and it keeps nuclear in the balance of its current contributions to our generating mix. My own view is that's a reasonable trade-off and reasonable value for the federal support going forward.
Appreciate it. I would like to let others testify or speak, but I've exceeded my own time, and I try not to use that as a chair. No one offered that they want to increase funding for cleanup of Hanford, but we'd sure welcome that at some point. Dr. Gingrey is recognized.
Mr. Chairman, thank you. Dr. Cochran, your testimony, you recommended that Congress should require that the Department of Energy resume a search for a second site to complement Yucca Mountain as a nuclear waste repository. You went on and criticized the Department of Energy, I think you said, corrupting the site selection for Yucca Mountain. Since the idea of utilizing Yucca Mountain has seen delay after delay, due, I think, in large part because of one Senate Majority Leader, it's hampered further usage of nuclear power because of the question of what do we do with the waste. So, therefore, until we finally open Yucca Mountain as the national repository for nuclear waste, I think it will inevitably prevent the federal government from adequately finding a secondary source. That being said, if you feel that the site selection of on Yucca Mountain has been corrupted, what do you believe will occur if any secondary site is selected? And additionally, where do you recommend we look for a secondary location for a nuclear waste repository?
Very interesting questions.
Well, you've had some very interesting comments.
I don't know that I have the answers, but let me make the following observations. Beginning in the Carter administration, there was a genuine bipartisan effort to solve the waste problem. They set up an interagency review to address this issue. And they came up and Congress passed what looked like a very good proposal. One agency, the Department of Energy, was tasked with going out and systematically finding the best site. Second agency, the Environmental Protection Agency, was tasked with developing criteria for assessing whether that should be licensed. And a third agency, the Nuclear Regulatory Commission, was tasked with making the judgment as to whether the site would meet those criteria. Now, in the decades since, that's gotten all botched. I mean, the site selection process was botched, and knowing how the federal government works, they'd probably botch it again. The development of the criteria was totally corrupted. It's not an independent agency, EPA, making these decisions. Before the decisions come out of EPA, they go into secret meetings at OMB, where EPA and NRC and OMB and Justice all get together to decide what the administration's position is. So it really isn't independent of DOE. And And here we are 20 years later, and we have no final EPA criteria to begin with.
Well, Dr. Cochran, excuse me for interrupting because I have a shortage of time here, but some of us on this side feel that maybe the process was corrupted politically more than it was by the administration and the agency.
That also.
I want to address a question to Mr. Fry. I don't disagree with Dr. Cochran's concerns about the nuclear proliferation potential of spent fuel, and obviously when you talk to the Germans, you know, that's always their big concern, and you can't ignore it. But where are we in regard to mitigating those concerns, in regard to reprocessing and indeed getting some of this spent fuel that's in the storage pools at the 101 current reactors in our country into a final depository? If you could address that for the committee, I think it would maybe allay some concerns that exist over this nuclear proliferation issue, because I firmly believe that the nuclear power, we need to go forward with it, but I'm taking too much time. You go ahead and respond to that.
Let me respond to it this way, Congressman. First of all, we are probably in the order of decades away from having a reprocessing and recycling operation at commercial scale to begin to deal with the nuclear waste in the form that has been proposed, for example, by the Energy, in which you recycle, don't separate plutonium, burn up the actinide, so forth. A lot of which can go into Yucca Mountain. But behind the question is in the intervening time a proliferation danger that we worry about? And basically, in terms of spent fuel, there are a lot of proliferation dangers, but one in spent fuel, as I understand it, is not very high, because spent fuel sitting at a reactor site or in an interim storage facility is not separated plutonium. It's very hot, and it's just not a really good source of material for a weapon. So I don't think that, and the Nuclear Regulatory Commission is basically storing this stuff first in a pool and then in a dry cask over a period of decades is perfectly safe. So I don't think that there is a large proliferation risk in taking our time to get the job done right on recycling and reprocessing.
Mr. Melanson was next, but he's absent right now. Ms. Richardson. Chandler. Mr. Smith is next.
Thank you, Mr. Chairman and witnesses. Dr. Cochran, I appreciate your testimony. Would you generally give a thumbs up or thumbs down to nuclear power?
Excuse me. Nuclear power is in the mix. It's a mature industry, and when it can compete with the other technologies on a level playing field, it ought to be, we should permit it to compete. That's setting aside the separate issue of whether you should reprocess the fuel. I think that's a terrible mistake. But the problem today is the new nuclear plants are not economical. These guys are coming up to the hill to get subsidies for a few new nuclear plants. It won't change the underlying economic problem they have. You need to cap carbon if you want to change the underlying economics. It's also the right thing to do. And then if it can compete, let it compete. But it's going to have to compete with a lot of new technologies that are going to be coming down the line, and it's going to be a difficult road for them.
And so you mentioned capping carbon. Is that through cap and trade policies?
Yes.
And what do you think the impact would be to electricity ratepayers, as an example, on cap and trade?
I think it would increase the cost of fossil fuels by initially a few cents, and then further out more, but I think that could be offset by a higher investment in improved energy efficiency in the near term particularly, which has a benefit in lowering the cost of electricity. And so the net effect over the long term, I don't think would, the effect on the economy, I don't think should be significant.
Okay, thank you. Ms. Kray, if you wouldn't mind responding, how much of our current electricity use in the United States could be generated by nuclear power using only domestic uranium?
Only domestic uranium? I might have to actually defer that to
Sure.
my USEC friend here.
Given the rise in prices that we've seen over the last several years, I think you're seeing resurgence in siting uranium mines and licensing new uranium mines. I don't think, again, you would ever have a substantial portion funded or fueled by domestic mines. I think you would still look to partners such as Canada and Australia to supply much of the uranium, but our ability to do maybe in 15 to 20% is very reasonable.
Okay, thank you very much. Thank you, Mr. Chairman.
Thank you, Mr. Smith. Mr. Rohrabacher is recognized for 5 minutes.
Thank you very much.
Excuse me, Mr. Rohrabacher. I didn't realize. Is Mr. Masterson, if you are teed up, then Mr. Matheson
I'm teed up.
is recognized for 5 minutes,
Right.
and then we'll follow by Mr. Rohrabacher.
Thanks, Mr. Chairman. I had a few questions I wanted to ask the panel relative to the waste issue, because I think the waste issue really is one that we need to move to some point of resolution if nuclear power is going to have a better opportunity. During the debate in Congress over the last few years on moving waste to Yucca Mountain, a number of members of Congress would get up during the debate and they'd say, gee, I've got all these nuclear power plants right in my backyard and I want to get this waste away. We've got millions of people living next door to this. Is it not true that as long as there's an operating power plant, there will be waste on site, even if you had an off-site storage disposal site someplace else, and there would be a reasonable amount of waste there that has to stay there for a few years before it can be moved? Is that a fair statement?
I can answer that, Mr. Chairman. By design, once the reactor fuel is removed from the core itself, it is placed into wet storage, and that is to accommodate the heat load that is still present then. But ideally, the original design of the plants was that once that time had expired, that it would be moved to dry cask storage, not for on-site storage, but rather to the ultimate repository. So if the repository were available, there would be a very short period of time while the fuel is in wet storage. But I would also add that while it was not the plan, having the dry cask storage on these facilities does not pose an undue risk. It's just outside of what the original vision was.
I'm glad to hear that, because that leads to my next line of questioning. But I wanted to first of all address that I think a number of members of Congress have inappropriately assumed that they wouldn't have nuclear waste in their backyard with an operating power plant. They will. They will, whether Yucca Mountain happens or not. It may not be the same amount of volume, but it will be there. Secondly, you mentioned that the benefit of going to dry cask storage. And back in 1982, I think, when Congress passed the Nuclear Waste Policy Act, I don't think dry cask storage was necessarily on the table at that point. That's where technology's taken us now. What do people think about the opportunity in terms of trying to resolve this complicated issue of looking at interim on-site storage, where we put the waste in dry cask storage, we leave it on site, the government takes title to the waste? That may address some of the concerns of the power plant owners. And from a cost basis and from an effort at trying to bring some medium-term resolution to this issue, it's not the million-year resolution, but maybe it's a 100-year resolution. How does the panel react to that type of proposal to try to move beyond the dynamic we're in now in terms of waste storage? I'd ask anybody on the panel.
Yeah, and I would offer right now the industry, as well as with the Department of Energy, is considering a number of alternatives. Included, I believe what you're suggesting is interim storage, not necessarily at the site at which it was generated, but perhaps multiple but more centralized dry cask storage facilities. Also revisiting the idea of closing the fuel cycle. And I think contrary to Dr. Cochran, what the intent of it is to develop the process by which you would not increase proliferation risks. So this interim storage would therefore avail the fuel for future reprocessing, just as was said earlier, to extract from it the energy that still remains in it. So I think all of those, whether it be the interim on-site storage, the more centralized dry cask storage, the reprocessing, but ultimately there will be a byproduct that's needed for Yucca
Understood.
Mountain. But in much lower volume and also a much significantly lower heat load.
Well, this line of questioning is motivated, and I want to hear from some other folks on the panel, but this line of questioning is motivated. I've introduced legislation that calls for interim on-site storage and federal government taking title of the waste. And I think it represents at least some level of looking at a practical step forward on this issue, as opposed to where we've been with substantial amounts of money being spent on Yucca, questions about the scientific analysis. Time is dragging on. We haven't met deadlines. We've spent a lot of money, and I think that there may very well be both an economic argument and a practical argument in terms of making progress on this issue as a medium-term solution, that we look at interim on-site storage with federal government taking title with dry cask. Do other people have a reaction to that?
Congressman, what you're doing is asking what I think is a very good question, and that is, let's ask ourselves, what's the safest and smartest thing to do with this stuff for the next 100 years? Well, we figure out what the safest and smartest very long term.
I would just add, from my perspective within the financial community, I think from investors, particularly as I've talked to them about potential commitments for new nuclear power plants, the waste issue virtually always comes up.
Right.
The NRC has always been able to determine that on-site storage or extended dry cask storage does not pose a safety hazard or a safety risk. There is a cost associated with it that would need to be dealt with, but I suspect that from an investor perspective and probably from the perspective of the companies themselves within the industry, some movement or progress toward an extended storage solution will be necessary before you see large-scale new plant commitments, because people will want to know what's going to be done with the waste. That's also probably true from the standpoint of state rate regulators, right, economic regulators as well. They're probably just as upset about the delays and the problems in waste disposal as the utilities are as well. So if Yucca Mountain is not going to move forward, some alternative that would provide an extended storage solution for the waste probably is necessary before we see substantial new plant commitment.
Thanks, Mr. Chairman. I would just offer again, I think it may be a more cost-effective method too. And if I can just add one point, a lot of people are still questioning the transportation risk of moving all this waste to Yucca Mountain. The interim on-site storage bill would address that problem as well. Mr. Chairman, I'll yield back.
Thank you, Mr. Matheson. I think that we could have a very interesting hearing just on this topic, and thanks for raising it. And the patient, Mr. Grossenbacher, is now recognized for 5 minutes.
Thank you very much, Mr. Chairman. Let me just note, and this is a side issue, but just again, Mr. Cochran, or Dr. Cochran, global warming is not the basis for making decisions like this. Even in your testimony, it's gone from climate change to global warming, and the fact that the fact that it's getting colder for these last 7 years has now taken the global warming people, so now they're saying it's global climate change, and that is such a mishmash. I think that reasonable people have got to, frankly, look at other issues rather than climate change for such incredible decisions as we're making today. However, with that said, I think you made some very good points about nuclear energy that need to be addressed, other than whether it's going to change the climate of the planet or not. I made sure my staff asked the panel beforehand and gave them some indication that I would be asking them about the high-temperature gas-cooled reactor. Have any of you been to Japan and seen the high-temperature gas-cooled reactor that they have in operation there? I went to Japan a month ago and went to that reactor. This reactor, from what I understand, after questioning the scientists there, as well as questioning various scientists, is lower in construction costs, lower in operation costs, has no risk of meltdown, has no risk of radioactive discharge, has no proliferation danger, and a major reduction in leftover nuclear waste. Now, what I want to know with first of all, that's what I understand. I'm not a scientist. You know, there's protons, neutrons, electrons, and morons in this universe. And I would have to say that I'm closer to the latter than the former. Maybe, am I wrong in seeing that there's a great potential in the high-temperature gas-cooled reactor that's just being ignored? Go right ahead.
I can offer a perspective on that. The high-temperature gas-cooled reactor design, sometimes referred to as Generation 4, they offer a promising option in the future, primarily because of the potential to divert that high process heat, whether it be for enhanced oil recovery in tar sands or even hydrogen production. However, I would differ from your perspective when you say about the cost. There's a number of issues right now as far as implementing them in the U.S. where they are significantly behind what's referred to as a Generation 3+, looking at what we want to implement next. Primarily, it's the licensing piece of it. They're not yet design certified by the NRC, where the others.
So in other words, it's the bureaucratic cost and not the technology
Not yet.
cost.
I would also add the size of them.
Yes.
And there's in order for them to be commercially deployed, there's the licensing aspect of it, and along with that, some safety implications. The NRC has indicated the need for more advanced fuel performance and characterization, as well as the selection of materials, again, because they operate at such a high temperature, which is to their benefit, but also a challenge. So with the cost, I would say any estimates of implementing them in the U.S. right now would be aspirational at best, and that is because of the lack of maturity of them at this time. Intuitively, I would think that they will be more costly than the light water reactors only because of their per kilowatt output or their size, and they don't have the economies of scale.
Well, actually, you can, if you have smaller reactors, you can actually place them in different places, maybe closer to the consumers, perhaps.
We've looked at that, I know, with the pebble bed modular reactor, and in the U.S. grid system, it still suggests that from an economy perspective, you would actually want to bundle at least 4 or 6 of those together. However, in development,
which you could do.
You could do, but then again, so that deployment or that distributed generation, which that is, doesn't necessarily win so much over here. But again, there is a strong future and outlook for those.
Okay, why is it, I guess what you're telling me, of all of what we've got now, this water-based reactors that we have now, this is 50, 60-year-old technology. These are things somebody designed 60 years ago that now have been incremental improvements on, but it's the fundamental concept of frankly, people who were raised and educated before World War II. And what I don't understand is that why there doesn't seem to be, I mean, listen, I went over and talked to those engineers. The Japanese engineers were not just Japanese engineers that had made their life on the high-temperature gas-cooled reactor. These were engineers that had a long history of their involvement in the nuclear energy field. All of them suggested that just the technology of it had all of these great benefits that I just suggested, especially the fact that there's no plutonium left over, which, as I say, Dr. Cochran's concern for that is very well. I disagree with him on global warming, but I totally agree with him on some of the points he raised that have to be concerns, like proliferation and the leftover waste material, as well as potential accidents. Were they lying to me when they said that there's no possibility of a meltdown or radioactive discharge as compared to light water reactors?
There is definitely a benefit with the high temperature gas cooled reactors because of the fuel type is ceramic in nature. It can withstand higher temperature and there is less likely to melt. However, I would say as far as the technology looking to be deployed next, That is being designed as we speak. So it is not archaic technology, but rather we see it from an operational perspective as the optimum balance between the innovation, using the passive approach to technology, but at the same time, the wealth of experience that we do have on light water reactors. Because again, as we go through, while the financial issues have dominated a lot of the discussions, at the end of the day, for us investing and operating, it's the safety aspect of it.
Well,
So
the safety operation, you're trying to tell me that light water reactors are going to be in just a safety comparison to what this high temperature gas cooled reactor offers, that there's a better safety potential for the water reactor?
I
With
think
all
it's
of the leftover plutonium?
I think it's unknown at this point. Well, I don't think that the plutonium issue is as much of a
what about the
differentiator.
meltdown issue? What about the discharge of radioactivity issue? I mean, these Japanese scientists were very specific with me about this. They'd all worked on the light water reactors before and said there is just no comparison as to the actual safety of these two operations.
I would again argue that there is a potential and there are safety benefits associated with the high temperature gas reactors, but at the same time, there are unknowns, again, in the area of fuel and also with the materials, which have implications, obviously, to the safety. But, so I think that the high temperature gas reactors need to be on the horizon, but I think the bridging technology to get from where we are to that is to implement the next evolution, not revolution, of technology to sustain the infrastructure to allow us to implement the Gen 4.
The gentleman's time has expired, but
Yes,
Admiral, it looks like are you trying to get into this? Do you want to say something quickly?
Yes, sir. I just wanted to add, and we're certainly my laboratory believes that high temperature gas reactor technology has a lot of potential. I don't think the Japanese engineers lied to you. I think they implied a degree of maturity in the technology that's not there yet. It holds a lot of promise. The issues, you got to finish developing the technology. You got to show that you can make this fuel and make it reliably in billions and billions of times. The other is the market for these machines, these reactors. Big light water reactors are very good at generating electricity, and they're very inexpensive in the U.S. context. These reactors, the high temperature gas reactors, are really focused at a different market, which is the high temperature process heat applications, including how you make hydrogen. In point of fact, a market that doesn't exist yet. So, we are committed, and the Department of Energy is committed to developing that technology and resolving those issues, and this is what we call reactor after next technology. It's not as mature, I guess.
Thank you. We'll have a second round, and Mr. Grossenbacher, for your information, Mr. Bilbrey had asked unanimous consent that your self-definition be concurred, but I would not consent to that. So, but I will recognize him for a second round.
Always willing to support my fellow surfer down there, whatever his motion is. Admiral, do you believe that there's going to be a resurgence of nuclear use and technology in the world?
Yes, sir, I do. And if I can just make one point, when we discuss other choices for energy, you have to consider the density of the source. If you're providing energy for a large industrial activity or a large population center, certainly we want to do everything we can with efficiency, because the cleanest megawatt is the one that's never used. We certainly want to do everything we can with renewables and distributed sources, but as I mentioned in my opening remarks, we have chosen a very energy-dense path. Today we satisfy the high concentration needs with hydro, with fossil fuel, and nuclear. And there are challenges associated with all three. When I add up the pluses and minuses, I think there's an important future for nuclear energy.
Do you believe it's important, in fact, almost echoing what Mr. Cochran said about the fact that other countries getting into nuke without the kind of oversight we have in this country, do you believe it's not only essential for us as Americans to be involved in this, but also in the issue of being involved in what technology and how this technology is being used around the world?
Yes, I do. We need to be leaders in those processes. I'll speak to that.
Yes.
I agree that with that conclusion. However, our leadership is misdirected towards closing the fuel cycle and developing a technology that simply has been demonstrated to be unreliable and far more costly than even the light water reactor.
Well, I understand that, Mr. Cochran. Admiral, there was discussion about the federal government's involvement in this industry. In the last 20 years, who has been the major purchaser of reactors within the United States?
In the last 20 years? No one.
Except United States Navy, right?
Yes, sir.
Okay. I just want to say that while we have sort of pointed fingers over the industry on one side, we have been the major consumer of reactors as a United States government, and then we wonder why has the federal government been involved with this issue when we have been the biggest consumer, the consumer for domestic sources. That being said, is when we, and one of the things I guess we need to point out that I think there's sort of this concentration of energy being needed to be sited at a certain location with the zero emission potential is not just an issue for electricity. Hydrogen production, if we're ever going to go there, either has to depend on using natural gas, which is, in my opinion, is going to be an essential transition fuel for mobile sources, or we're going to need to go to some way we can concentrate the energy for hydrogen and, for those of us in California, desalination, which we're already seeing. I don't know what other technology not only provides that option, but I think the one bum rap that I keep hearing is that when you look at the life cycle, the true costs, not the regulatory or legal costs, but the true costs, hydro where you can do it, wind generation where God's put it, and then nuclear. Overall, you compare that to the other cost, life cycle, I don't think this is one of those issues we got to choose between the economy and the environment. But my concern is this. We need to start shutting down major emitters of greenhouse gases now. We can't wait 20 years, 30 years. How do we shut down coal plants across this country without going to some kind of technology that's able to concentrate it down the line? So let me just say this. We were looking at the cost. Ms. Kray, what percent, how much effect does government regulation and litigation and tort exposure have to do with the overall costs? And I would and then I'd turn around and say, Mr. Cochran, one of my concerns is my state has outlawed one of the options that has been pointed out by the UN Council on Climate Change, has outlawed that technology. At the same time, in California, we're talking about taking a lead on it. So let's talk about the regulatory, and I guess let me go back and say from the investment point of view, isn't the regulatory and the tort issue the dark cloud on the horizon when you're talking to investors?
And I offer that. So the NuStart consortium was formed to address that. You can use the word shore 'em and recognize the failure of that investment process. So that is what is on the minds of investors going forward. And part of the changes in the licensing process that the NRC invoked was to address that and to essentially pull forward all of that litigation risk before the tremendous capital investments are made. And that was not the case when the current fleet was built, where in effect you were pouring in your capital investment at the same time you were at the mercy of the regulatory process. So that huge uncertainty still is in the minds of investors, whether it's from the utility side or from the financial community itself. So our belief is that with the revised Part 52 process that will improve that, but nevertheless, our objective is to demonstrate that by getting a license in hand, again, prior to making those huge investments and to avoid the situation you're referring to.
You're exactly right, Congressman. That concern is foremost in the minds of the investment community. We have a new process. I personally believe that process will work effectively. If you have essentially complete designs that the NRC has reviewed and signed off on at the outset, if you have an opportunity to go through literally all of the environmental and safety issues around the plant before you start construction, then the risk of a problem or a surprise down the road, particularly after the capital investment in the plant has been made, ought to be relatively low. The problem is that we've got the new process and it hasn't been tested, and until we get several plants through that process and it performs as everyone intends, the financial community will look at that and say, there is a risk and an uncertainty here. Nuclear, what sets nuclear apart from every other alternative form of generation is the requirement to go through the NRC licensing process. And so that is the difference, and until we have a track record of successful performance for the new system, that uncertainty will be there.
Now, I've served on 2 environmental regulatory agencies, some of the best in the world, I think we'd agree, and I've been proud to serve on those groups, California Coastal Commission and the Air Resources Board for California. But getting back to the Admiral's statement about we're talking about a concentration of energy generation, what we've seen here is also a concentration of capital and deep pockets that attracts the type of vultures who swoop down and are looking to take their pound of flesh, and becomes a huge target to be able to generate great revenue through regulatory obstructionism and legal proceedings. And we need to address that thing, Mr. Chairman. I guess what it really comes down to is this attitude of just back off and let the system work, is the fact that we've basically have tied this industry down, and then based on the fact that they can't move, and then say, why haven't they done more? And I think there's a real challenge that we got to be more proactive on this. And as I stated before, don't think the other industries that right now are the fair-haired groups aren't going to have litigation, and come to San Diego County and take a look at the litigation against the links that are going to solar, wind, and geothermal. It's a huge uproar in a community that's very environmentally sensitive. So all of these things in the long run are going to have a lot of baggage, and we need to be proactive rather than reactive on it. Thank you very much, Mr. Chairman.
Thank you, Mr. Bilbrey. And Mr. Rohrabacher is recognized for our final question.
Oh, well, thank you very much. I've been listening very closely here, and it seems to me that what we've got here in the United States is a corporate mentality that's only interested in trying to make more money off the current status quo, and only very short-term vision. And any vision that they have for the future is not being based on something new being in the picture. It's all based on status quo technology. And again, nuclear energy isn't all that new. We're talking about something, the fundamentals that were set down by what we're talking about, something that was designed by people who were educated before World War II. And it's basically 50-year-old technology that has been incrementally improved. I think the idea of focusing our research on reprocessing plants that can help solve a part of the problem is a good idea. But what I'd like to know, if we can't rely on corporate America to come for innovations, we got to rely on government policy. How much money has been going into research and development, federal dollars, in terms of developing this high temperature gas cool reactor concept, as compared to just incrementally improving the light water reactor concept?
I can speak to, from the standpoint of the improvement of light water reactor technologies. There's been very little federal government investment in research and development. There is an ongoing effort for a cost-shared program between government and industry, so that the research tools of government can do what industry can't do or doesn't have the capabilities to do, to ensure the extension of that technology. In terms of the high-temperature gas reactor in the United States, the project that means to deliver that capability is the next generation nuclear plant. there is an ongoing program to develop and demonstrate that technology at a scale that will then convince commercial interests that this is something that they want to buy.
Why is it that the Japanese have one of these working and we don't?
Well, they have a test reactor.
That's correct.
It's not industrial scale.
It's a big reactor. I'll have to tell you, I went there and I went through the reactor myself.
South Africa has a aggressive developmental program in this area, and again, we think, and I speak just from the standpoint of reactor technology and our perspective at the Idaho National Lab, this is a very important future technology. It's also complicated. You've got to prove the fuel performance. You've got to prove that you can manufacture the fuel, and the fact that you can do it once in a test reactor and not stress it or demonstrate it at industrial scale, there's lots of uncertainties that have to be resolved. So that refers to my comment as perhaps the folks you talked to were a little bit aggressive in terms of their estimates on the maturity of the technology. Having said that, Congressman, I'm with you. I think this is an important technology, but reactors are not simple things.
Listen, I believe, first of all, as I say, the criticisms of the current system is justified. We got plutonium left over, and we've got waste problems, and we've got risks associated with it. I am dismayed that we have a situation where we have a potential alternative nuclear option that is not being fully looked at, that the Japanese and the Russians, of all people, are engaged in actually moving forward on this technology at a much faster pace than we are, and that we will be left behind because of corporations' inability to basically look forward and have long-term strategies, and our government, which seems to be unfortunately too tied to the hip to major U.S. corporations, that we're being dragged back and not being able to make these investments in future technologies. So I think this is a great risk. I think we could wake up. Look, I am the benefit, Mr. Chairman. We are the benefit of that World War II generation. My father helped develop the things that right now, and his generation, that are now solving the problems that we face today. But there are future problems, and unless we are the ones that are open to new ideas, rather than totally focused only on incremental improvements of the status quo, we will be left behind a generation from now, and our kids will not be the leaders of the future, as Americans have been for the last 30 and 40 years, based on the work of our parents. So I would hope that we live up to the great generation's challenge to us and remain the world's leader. And energy is so important, and I believe that the high-temperature gas-cooled reactor is an example of something that we should be putting maximum attention on, and instead it's being pushed to the side and out of the picture. So thank you.
If I could comment on that.
Sure.
If I would agree that the U.S. has fallen behind in its leadership of the nuclear industry.
Right.
But at the same time, I think we have a very similar view of the high-temperature gas-cooled reactor, as does the Asian market, particularly Japan. I think we both see it as prototype, somewhat developmental in nature. Through Admiral Grossenbacher's areas, we need to look at the fuel characterization and the materials issues. But if you look at what Japan is building and purchasing now, it is not high-temperature gas reactors. They are building the light water advanced reactors.
They've got the same problems with their corporations that we do.
And I think, and again, when we put out a request for proposal for additional baseload power, we do not limit it to anything. We look at coal, any renewables, and nuclear, and within the nuclear family, whoever responds. The answer is there was no response of a high-temperature gas-cooled reactor, and that's because it's not yet ready for the commercial deployment. But we're hopeful that as we sustain this infrastructure, there will be deployment of HTGRs, whether it's for electricity production or some of the other benefits that it can provide.
Well, I'll be going to Russia to look at their operation and some of the issues that you brought up, and I think this really deserves the attention of the committee, and I thank you very much for giving me this time.
The gentleman's time has expired. I know, Mr. Cochran, you'd like to continue, but Let me say this. You have been an excellent panel. We have not closed the record. This is not the extent of this dialogue. This is one that we want to continue. We need to continue. There are not easy answers here. We're all going to have to talk about it in a collaborative way, and we will continue on this committee to do that. So under the rules of the committee, the record will be held open for 2 weeks for members to submit additional statements and any additional questions they might have for the witnesses and the hearing, but the subject is not adjourned.